हेलो एवरीवन। हेलो एवरीवन, वेलकम टू YourPedia। तो ऑडियो वीडियो क्लियर है? एक बार बता दीजिएगा। जितने भी स्टूडेंट्स लाइव हैं एक बार जस्ट मुझे कंफर्म कीजिएगा ऑडियो वीडियो क्लियर है। जितने भी स्टूडेंट्स लाइव हैं एक बार जस्ट मुझे बताइएगा ऑडियो वीडियो क्लियर है। क्लियर है ऑडियो वीडियो? ठीक है, ठीक है, चलो। तो हम लोग बेसिकली HPCL का जो भी आपके अभी तक के ऑफिसर्स के मोस्टली द पेपर्स प्रीवियस ईयर the all the questions of soil engineering we are going to discuss here. Means there will be all the questions in previous papers from 21 to 25, all the questions that have came in your syllabus for for soil engineering. In today's class approximately 55 questions are there. All the 55 questions we are going to discuss here. Okay, so once please confirm if audio video is clear, then we are going to start the session. Okay, okay, right. So starting with first question, what is the liquefaction phenomena about soil failure? First question, he is asking you, tell me about the liquefaction phenomena. Liquefaction phenomena you are generally studying in the shear strength of the soil. When the shear strength of soil becomes zero, due to what? Due to oscillatory motions or due to some dynamic loadings like earthquake. If your value of shear strength or soil loses all its shear strength, then a phenomena of failure occurs mostly, that is known as liquefaction. There is also one condition where effective stress also becomes zero, that is your quicksand condition. But here he is asking about liquefaction. What is the liquefaction phenomenon about soil failure? When he is asking about liquefaction phenomenon, always remember sand. It will always happen in a loose saturated sand. First thing, if he will ask you where is liquefaction going to happen, liquefaction is always going to happen in loose saturated sand. So first question he can ask you like this. Second question he can ask you, what happened when liquefaction occurs? When liquefaction occurs, sand loses its shear strength due to what? Due to its oscillatory motion. Due to its oscillatory motion, sand loses its shear strength. Second option C, failure of the soil under liquid retaining structure. Failure of the soil under liquid retaining structure, that is due to quicksand, or where hydraulic gradient becomes equal to critical hydraulic gradient. There also you can say that is basically piping failure or uplift failure. So always remember, if he will ask you about liquefaction always occurs in loose saturated sand. When loose saturated sand loses its shear strength, due to some type of dynamic loading like earthquake or like vibratory or like oscillatory, then in that case what will happen? Liquefaction will happen. Okay, moving on to next question. Here solution is also there. See, correct answer is C, sand loses its shear strength due to oscillatory motion. Liquefaction is the phenomenon in which saturated loose sand, I told you what, saturated loose sand, okay, shear strength and stiffness under cyclic or earthquake type of shaking starts. Okay, moving on to second question. He is asking you select the false statement regarding soil classification according to ISCS. He is asking you select the false statements, means from all the four statements which statement is going to be incorrect. He is just asking you. So let's read the statements. Soil are broadly classified into three divisions. Yes, I see what is ISCS. When you will see, there are three divisions of the soil. The first division is known as coarse grained, the second is fine grained, and third is your highly organic soil. Like peat. Okay. Second, see, in case of coarse grained soil, if fines are more than 12%. See, when we are studying ISCS, Indian Standard Soil Classification, we would be having approximately three types of fines consideration. One, when fine is less than 5%, we don't have to denote the fine. First condition was that if the fines are greater than 12%, in that case what we were doing, अगर आपका फाइन्स 12% से ऊपर हुआ तो उस केस में we have to denote the fine grained soil also, and the border case was between 5 to 12. Between 5 to 12 there was, we are using dual symbol. Then see what he is telling, in coarse grained soil, if fines are more than 12%, borderline case will not require. Generally borderline case will not require. Here what will require? Here you will tell what, you will not use dual symbol, you will if GC is there, if clay is more, you will tell GC, if silt is more, you will tell GM, with what, with GW, GM, GW, GC, like this you will tell. Okay, So this is wrong. Third, the fine grained soil in ISCS system are subdivided into three categories. Obviously, these are basis on fine grained what? Clay, silt, and organic. And in that also there are compressibility criteria: high compressible, low compressible, and intermediate compressible. Black cotton soil of India lies partly above A line, partly below. Yes. So black cotton soil, when we will study, sometimes black cotton soil is partly above A line, sometimes it is below A line. So the statement wrong is this one. So you can say your correct answer will be in this will be B. So correct answer will be B. Is it clear? Can we move further? So coming on to solution. See, in case of coarse grained soil, if fines are more than 12%, border case lines are required dual symbol. Yes, agar fines आपका border case required dual symbol in ICS divided into three main categories. So these are your consideration. Okay. Can we move further? Okay. Your answer is B. Borderline cases are not required. Third, see, in consolidation test, when the load is changed from 150 kilonewton per meter square to 200 kilonewton per meter square, just tell me the volume void ratio changes from 0.6 to 0.55. Calculate the coefficient of volume change. He is asking about coefficient of volume change. Just calculate and tell me the answer first. Just calculate once and tell me the answer. Just tell me the answer. Okay, see, first thing, always remember, here he is asking you about coefficient of volume change, not coefficient of compressibility. First thing, always remember, he is asking you about coefficient of volume change. There are coefficient of compressibility AB. Like mostly what will happen, you will direct jump with AB. But don't do that mistake, because he is asking you coefficient of volume change. Coefficient of volume change comes out to be what? Coefficient of volume change comes out to be MV. MV formula is what? AB by 1 plus E naught. MV formula is what? AB by 1 plus E naught. AB is what? Your coefficient of compressibility. Then AB, what we can put, sir? AB we can put, what was AB? Change in void ratio divided by change in effective stress divided by 1 plus E naught will be your formula. Change in void ratio. Initially void ratio was 0.6, then it comes to be 0.55. So initially void ratio was 0.6. After that void ratio comes to 0.55. Change in stress. What is the value of change in stress? Change in stress is from 150 kilonewton meter square to 200. So it will be 200 minus 150, and this whole divided by 1 plus E naught. Initial void ratio means more void ratio. The void ratio which was initially when we have started the test, that is your 0.66. That is your 0.66. So this value is your 0.66. Okay. Sorry, 0.660. It's not 66. 0.60. So this comes out to be further 0.05, because 0.60 minus 0.55, it comes out to be 0.05. Here it comes out to be 50, and divided by 1 plus 0.6. Further solve करेंगे. 0.05 divided by 0.05 divided by 50 divided by 1.6. Then if you will solve, this comes out to be how much? This comes out to be 1 by 1600. 1 by 1600, option is there, meter square per kilonewton. 1 by 1600 meter square per kilonewton is your answer. 1 by 1600 meter square per kilonewton is your answer. So answers comes out to be 1 by 1600 meter square per kilonewton will be your answer. One thing always remember, he is not asking here coefficient of compressibility. He is asking you coefficient of volume change, and coefficient of volume change comes out to be MV. If he will ask you coefficient of consolidation, remember he can ask you the unit. What will be the unit of coefficient of consolidation? He can ask you multiple types of question here. So in consolidation, always remember 3 or 4 things. One is your all the values, like coefficient of consolidation is what, coefficient of compressibility is what, coefficient of compression is what. Coefficient of compression, some values are there: 0.07 WL minus 10, 0. For remolded, for undisturbed, remember that values. Another thing, when we are going further, remember about degree of consolidation U. From U we will derive TV value. TV is equal to CV into what? T by D square. That formula is most important, because in here also, in this session also, there are more number of questions from that formula only. Okay, so remember these things. So here answer will be what? Answer will be 1 by 1600 meter square per kilonewton. Clear? Can we move further? Okay. Okay. Tell this, which of the following curve represent a poorly graded soil given in the figure below? Here he is asking you which of the curve will represent about poorly graded soil. Which of the curve will represent about poorly graded soil? Can you please tell me? Just fast. Can you please tell me? Can you please tell me which curve is representing poorly graded soil? Those who are live, please answer. These are very good questions. These are very good questions from soil mechanics, which will help you further qualify your HPCL exam. What is asked? Which of the following curve represent a poorly graded soil? See, always remember, poorly graded soil means what? Poorly graded soil means in soil where all the sizes approximately same type of soil. Like it's from, if you will say gravel size varies from 4.75 to 80. If the size is just for gravel only, then we can say soil is poorly graded. If the size is frost sand only, then also we can say poorly graded. From then also we can say one thing, if the curve is steep, then also we can say poorly graded. So here if we will see curve D, starting from curve D, if we will see curve D, it is starting from where? It is starting from 20 and it is going up to 0.0010. Means in this soil there are different fraction sizes of particles available. So this will not be obviously poorly graded. You can see F also. In F also, what is there? Coarse grained and fine grained, both are there. You can see for C also, you can see for B, just see for B what is there. See, B is having a steep curve. B is having a steep curve means only one fraction size of particles are available in this soil. Then it will become what? It will become your poorly graded soil. It will become what? It will become your poorly graded soil. Okay. Coming on to answer. Curve B, a poorly graded soil, a steep single peaked curve of the grain size distribution graph indicating a lack of intermediate particle and high uniformity. Means Cu value will be less than 6 and Cc value will not be between 1 to 3. Then that will be what? Then that will be your poorly graded soil. Okay, moving to next question. Tell here, the given figure depicts typical load settlement curve from plate load test for different types of soil. Select the correctly matched pair. He is asking you to select the correctly matched pair. From this, which of the pair is correctly matched? First look at this diagram, then I will show you all the options. So you have to depict from here. These are your option 4. These are your 4 options. Tell me. See, when he will ask you like this question, you have to remember in foundation engineering, when we are dealing with modes of failure, there are 3 modes of failure. One is general shear failure, one is local shear failure, one is your punching shear failure. In general shear failure, mostly you will get dense soil, like dense soil or stiff soil. In that, what will occur? In that, generally your general shear failure will occur. In that, you will get an exact point from where failure starts. But mostly in local shear failure or punching shear failure, failure will be progressive in nature. Means you cannot tell a point where the failure starts. So here we can see, if you will see curve 1, see in curve 1 what is happening? Up to here, the strain is very less as the pressure is increasing. Up to this point, the settlement is very less as the pressure is increasing. But suddenly at this point, see, you are not increasing the pressure, then suddenly settlement starts rapidly. Means at this point your soil has lost its all resistance, and from there settlement has started, But type 3 and type 2 are what? Type 3 and type 2 are your progressive or ductile failures, like you will see in loose sand, like you will see in soft clay. There you will not get a fixed point where the failure will start. There you will not get a fixed point जहां पे आपका failure शुरू होगा. तो देखो कर्व 2 टिपिकल डेंस सैंड, बात ही नहीं है, वी कांट से. कर्व 1 टिपिकल ऑफ द लूज सैंड और सॉफ्ट क्ले, नो. कर्व 1 is your typical of the dense sand or gravel or stiff clay wherein general shear failure. So we can go with curve 1, because curve 1 is what? Typical dense sand or gravel jahan pe wherein general shear failure occurs. I hope this question is also clear to you all. See, answer. Curve 1 is a typical dense sand or gravel or stiff clay bare in plate load test. Where we will get this graph? From a plate load test we can get this graph. Here options are also explained. Why other options are not there? This is also explained to you. I will move further. Question number 6. Just answer question number 6. What it is telling? Just give me a second. I hope. Just answer question number 6. What is question number 6 telling? Just answer. Dash is the intensity of loading that will cause a permissible settlement or a specified settlement for the structure. Means he is asking you which of the intensity will tell you which will cause permissible settlement. Always remember, when you will study foundation engineering, there are two types of failure. One is your shear failure, one is your settlement failure. Whenever he will talk about shear failure, he will always talk about capacity. He will always talk about capacity, bearing pressure, bearing capacity, or he will tell you ultimate bearing capacity, net bearing capacity, safe bearing capacity. He will always. But whenever he will talks about settlement, he will always talk about bearing pressure, not capacity. He will always talk about bearing pressure. He will not talk about bearing capacity. Whenever settlement criteria comes, he will always be talking about what? He will always be talking about safe bearing pressure. So dash is the intensity of loading that will cause a permissible settlement or specified. That is your safe bearing pressure is the intensity of loading that will cause a permissible settlement or specified settlement of the structure. Is this clear to you all? Just please tell me, then we will move further. Is this clear to you all? Just tell me, then we will move further. Okay. What will be the answer? Safe bearing pressure. See, answer is your B. Safe bearing pressure is defined as maximum intensity of loading that the soil can safely carry without excessive or unacceptable settlement. Okay. So ultimate bearing capacity represent the maximum load causing shear failure. Safe bearing capacity is about settlement. So always, if you will talk about settlement, always remember safe bearing pressure. Answer this question. Here in this question, he has asked you about capillary height. He has asked you about maximum capillary height. See, always capillary height related questions. One is your standard formula, what you will use, like that 4 sigma, something about that is your standard formula. There are certain formulas which we can also use here. What? H is equal to C by E into D10. One formula was there for you. H is equal to what? H is equal to C by E into D10. This is also one formula to find what? To find capillary fringe, to find maximum capillary height. Maximum capillary height. Okay. Values are given here in the question. Yes, sir. Values are given here in the question. What are the values? Just tell me. C value is what? C value is 30. C value comes out to be 30 in mm square. Okay, because this is your empirical formula. Don't try to convert. C is your 30 mm square. What is your effective size? Void ratio is 0.5. Effective size is your 0.015. So if you will see from here, the value comes out to be 15 into approximately 5. This value comes out to be how much? This value comes out to be approximately 75. Here it is your 30, approximately 4, because 4000 mm will be there. Okay, 4000 mm. From there, if you will see what will be your capillary fringe, it will be your 4 meter. So answer will be what? Answer will be your D. Answer will be what? Answer will be your D. So see, solution is this. The maximum capillary height rise is given by SC is equal to C by E into D10. What is D10? D10 is your effective size. Effective size. Always remember, if he will ask in question about effective size, that will always be D10. This is also known as Allen-Hazen size. Allen-Hazen size. Always remember these things because these are going to ask in the questions. Okay, answers comes out to be how much? 4 meter. Just identify the false statement regarding the standard penetration test. He is telling you to identify the false statement about standard penetration test. First of all, he will ask you, why is standard penetration used? Standard penetration test is used to find the ultimate bearing capacity of the soil. In shallow foundation, we will use standard penetration test to find what? Ultimate bearing capacity of the soil. What he is asking? This is extremely useful for determining the angle of shearing resistance for cohesion. Obvious angle of shearing resistance you can determine from here. This is most commonly used for in situ test, especially for cohesionless. Okay, in situ BA. This test is extremely useful for determining, because yes, if you will study If you will study standard penetration test, SPT test, there is one line written in first only. Standard penetration test is used. This is used to determine many things. This is used to determine angle of shearing resistance. This is used to determine relative density. This is also used to determine unconfined compressive strength also. This is used to determine what? Angle of shearing resistance. Second is comes out to be, first is your angle of shearing resistance. Second comes out to be what? Second comes out to be relative density also can be determined. Third comes out to be unconfined compressive strength. It can also be determined. Unconfined compressive strength. Unconfined compressive strength. It can also be determined. So what will be your answer? D will be, I hope, your answer, because what he is telling in D statement, he is telling in D statement, their test cannot be used to determine unconfined compressive strength of cohesive soil. Though this will be your answer. Means you can also determine unconfined compressive strength from this test. So what will be your answer? D will be your answer. I hope we will move further. Is it clear to you all? We will move further. No problem. Okay. See, what is your answer? D is your answer. Tell me, which type of slope failure is represented in given figure? In given figure, which type of slope failure is there? It is not toe failure, because if it will be toe failure, it would be passing from here. It's not face failure, because face failure is above what? Face failure is above toe. So what is this? This is your base rotation failure. What is this? This is your base rotation failure. So this is your base rotation failure. Always remember, from stability of slope, though in the finite stability, it will always ask you about the finite stability. From there, this is one important question, modes of failure. There he can tell me what is face failure, what is toe failure, what is base failure. If your failure plane is passing from here, then it will be what? Then it will be what? Your toe failure. If failure plane like this, see, if your failure plane is like this will be what? This will be your toe failure. But your failure plane is passing below the toe. This is your base failure. And base rotation failure, basically. Base rotation failure. I hope this is also clear to you all. Okay, we will move further. Which type of slope failure is represented in given figure? Base rotation. Here he can give you height also, and he can ask you height of the failure surface and depth, height of the embankment and depth. From there also, if it is equal to 1, then it is your toe failure. If greater than 1, then the values will be different. Okay, so you can see here, what is your answer? Base rotation failure. In base rotation failure, the slip surface passes through toe and extend to the deep in the foundation beneath. Okay? This underlying soil, when this will happen, when underlying soil is weak as compared to above soil. When your underlying soil is weak as compared to above soil, this failure will occur. Okay, moving further. Tell me the answer of this question. Those who are live, please tell me. What he is asking? He is asking, calculate the minimum depth of foundation required as per Rankine's analysis for a building. See, he will always ask you, because when we are teaching foundation engineering or when we are teaching consolidation, total settlement consists of three things. One is your immediate settlement, one is your primary consolidation settlement, one is your secondary consolidation settlement. And sometimes when you will study foundation, there will be a formula for minimum depth of foundation, D minimum. Minimum depth of foundation, D minimum, comes out to be P intensity by gamma 1 minus sine phi divided by 1 plus sine phi whole square. This is your formula for minimum depth of footing, minimum depth of foundation as per Rankine's analysis. Means your depth of foundation should not be less than this value if you are determining minimum depth. See, basically, if we will find what is 171 is your intensity, divided by what is your gamma value. Gamma value given in the question is 19. Sin theta is your 30. 1 minus sin theta, 1 minus sin 30, 1 plus sin 30, and uska then we have to do its square. If we are doing its square, sin 30 value comes out to be how much? Half. So this will become what? This will become 0.5. This will become 1.5. We can also say this is 1 by 3. 1 by 3, 171 by 19. How much? 171 by 19 comes out to be 9, because 19 into 9 is 171. Here if we will see 1 minus, this is 0.5, this is 1.5. 0.5, 1.5 square. You can also tell 9 into 1 by 3 square. You can also say 9 into 1 by 9. From here we can conclude this comes out to be 9, 9 cancel out. this comes out to be 1 meter. So minimum depth df minimum df minimum comes out to be how much? Df minimum comes out to be 1 meter. Option is given 1 meter. So solution becomes 1 meter. So how much will be the solution? Solution will become 1 meter. Always remember, like this kind of question, he will always ask you. Can we move further? Okay, proceeding. Tell me. This is a good question. What he is asking you? What he is asking you? Tell me first. The ratio of liquid limit minus natural water content to the soil to its plasticity index. What he is telling? He is asking you, tell me the ratio of liquid limit WL minus natural condition water content W divided by plasticity index. What is plasticity index? WL liquid limit minus WP plastic limit. What? WP plastic limit. This consists of equal to what? This consists of equal to consistency index. What is this? Consistency index. Consistency index. IC. Always remember. Consistency index formula is what? The ratio of difference of liquid limit to the natural water content to bracket to bottom. What will come? It will come plasticity index, which will be equal to liquid limit minus plastic limit. So what will be your answer? Consistency index. If he would ask you liquidity index, just the change will be what? Wn minus Wn. Wn, it will change. Okay, so remember. Can we move further? Consistency index, see, liquid limit minus natural and natural water content divided by plastic limit. Tell me this answer. A clay sample has a dry density of 1.85 gram per centimeter cube and G value is 2.71. Estimate shrinkage limit of the clay. He's asking you about shrinkage limit. This is also a good question. See, whenever this kind of question you will ask, there are two formulas which we can use. One formula is we will go from basic. See, we will go from basic. You would remember dry density. Dry density is equal to what? G gamma W upon 1 plus E. Always remember, G, what is dry density is equal to G gamma W upon 1 plus E. We can say from here, sir, if we will take rho D is equal to what? G rho W upon 1 plus E. Okay, we will proceed with this formula because this formula is always easy to remember. If we will take direct formula from shrinkage limit, most of the you students will always not remember that because there are so much formula. So we will go from basic. It will be always easier for us. So we can say here, what is your rho D? See, don't put gamma D because he has given you what? He has given you dry density, not its dry unit weight. It's dry density. So if we will put here 1.85 gram per centimeter cube, G value is how much? G value is 2.71 into rho W is how much? Gram per cc, we will use value as 1. See, always rho W in gram per cc, how much you will use? 1 gram per cc. So when this value comes out to be shrinkage limit, we have to determine 1 plus E. Just tell me the E value from here. E will be equal to 2.71 minus 1.85 divided by 1.85. How much value is coming? E value 0.43 something? 0.46 approximately. 1.85 only? Yeah, 0.46. So E value comes out to be 0.46. You always remember first interrelationship formula. Always remember first interrelationship formula. What was that? S into E is equal to W into G. First interrelationship formula, S into E is equal to W into G. Always remember, in question he has asked you about what? Shrinkage limit. In shrinkage limit, when the soil is at shrinkage limit, degree of saturation is equal to 1. At shrinkage limit, degree of saturation value is what? Degree of saturation value is always S equal to 1. So we can put here S equal to 1. If we will put here S equal to 1, E value how much? 0.46. W value we have to determine because this is your water content at shrinkage limit. Shrinkage limit water content. I am giving you see full solution because if there will be any doubt, you can cover from here. Into G value is hard. G value is 2.71. So W comes out to be how much? 0.46 2 divided by 2.71 or equal to, what will be equal to 17.15 approximately, you will get the value 17 point. If in percentage we will say, it will be point how much, 1715, and if percentage 17.15 percentage will be your value. So from here, see, your calculation should be somewhat good, because see, the options here are very close. So answers comes out to be 17.16%. So answers comes out to be 17 points. So at shrinkage limit, what will be your water content? Your water content will be 17.16. Same question he has asked further also. Yeah. Yes, Shubham. Shubham, just join the group also. You can join the group, or you can comment below this section. You will, I will provide the PDF. You can comment below this video. Okay, tell me, which of the, you can comment below this video. I will try to provide you the PDF. Which of the following is a classification of piles? After this video is over, then you can comment. Which of the following is a classification of pile based on mode of transfer of load? He is asking about, see, classification of pile is there on many methods, like on construction, on cross section area, on many methods there are modes of transfer, classification of pile. But he is asking about mode of transfer. When he will talk about mode of transfer, there is end bearing pile, because he is talking about how load is transferring. Then when we will take that case, how load is transferring, there comes, like, which of the following is a classification of pile based on mode of transfer? End bearing piles, friction pile, combined end bearing and friction. See, fender piles are depending upon the situation. Fender pile, sheet pile, like if you have to construct in a marine areas or docks, there are different types of pile can be used. So these are the piles on basis of place where you are using. Compaction pile is used in loose sands. Like sheet pile are used where you want number of piles in a circle or number of piles in a line, there you can use sheet pile. But if he is asking about on load transfer, then what will be there? It will be mode of transfer, end bearing pile, friction pile, or combined and friction pile. Okay, we can move further. These are on the type of construction material. These are on the type of construction material. These are on the type of driving, how you will do. Okay, see, this is there. Okay, what is the minimum center to center spacing of friction piles if diameter is D? As BIS, Bureau of Indian Standard, it's 3D. As we know, what is the minimum center to center spacing for friction pile? For friction pile, minimum center to center spacing you will keep is as 3D. How much value you will keep? You will keep the value as 3D. Always remember this. You will keep the value as 3D. See, these are not conceptual things. These are the remembered two things, because you have code, their value is given. It are all what? It are all things to be remembered. So see, in HPCL paper, there always two things will happen. If there are 85 technical questions, approximately 50 to 55 questions will be direct. Direct means you will see the question, you can take. Other 20, 25, 30 questions will be where you have to solve. Here also some questions are like that, where your concept will be used, where your awareness will be used mostly. Okay, can we move further? Okay, see here. What is the value? As per, correct answer is your what? Correct answer is your 3D. Moving further. In which of the soil capillary rise is expected to be maximum? See, he is talking about capillary rise. Capillary rise is maximum in which soil? Mostly clayey soil. Or mostly here we can say silty clay, because silty clay is only soil where particle size is very fine as compared to other options. See, here if it would be clay, we would have gone with clay. If here it would be clay answer, we would have gone with clay. But here options we will match. Sandy gravel, not possible. In gravel, the capillary rise is least, because what? The diameter of particle size is inversely proportional to h. H is inversely. Height of the capillary rise is inversely proportional to size of the particle, So here, in which soil capillary rise is expected to be maximum? Sandy gravel, not option. Sandy silt is not. Silty sand, what is your option? Silty clay is your option. In clay, capillary rise is approximately 30 meter. When you will study, when you will do the practicals, when you will see, in clay, capillary rise approximately goes to 25, approximately 30 meter, up to 30 meter it goes. See, the answer is your silty clay. Capillary rise in the soil depends on the size of pores. Small pores produce greater capillary action. Fine grained soils like clay and silty clay have small pore spaces which generate highly capillary forces. Okay, moving further. This is also good question. Solve this fast, everyone. Those who are watching this, these are good questions. See, if you are giving any exam, rather it will be AE, JEE, any exam, rather it will be AE or JE, any exam you are giving, these are one of the best questions from soil mechanics. These are one of the best questions from soil mechanics. No doubt, which exam you give, like this kind of question will be always be given to you. Okay, so JE exam, AE exam, any exam you give like this kind of question, it always be there. ठीक है, तो जैसा भी एग्जाम आप दोगे वैसा आपको इस तरीके के क्वेश्चन मोस्टली मिलेंगे. ठीक है, कैन वी मूव? सी व्हाट इज गिवन, a shear vein of, see one thing always remember, the data in this question are for only confusion, for only confusion, because what he has asked you, always remember, he has asked you sensitivity of soil. First of all, remember what was sensitivity of soil. Sensitivity of soil means when your clay loses its strength without change in water content. If you are remolding your clay, there is no change in water content, then also strength of soil getting loose, it is losing its strength, that is known as the property sensitivity. Sensitivity property is that property where soil loses strength without change in water content. So what was sensitivity? Unconfined compression strength in undisturbed state to the unconfined compression strength in remolded state. When we are doing vein shear test, there also one formula we have acquired. When sensitivity we have to find, see in vein shear test what is happening, the vein is getting rotated, the vein is getting rotated, it will depend. See, if torque is more, means soil is in undisturbed state now, because it is giving more resistance, it is giving more resistance. And when torque is less, what is happening, your unconfined compression strength will be less or your shear strength will be less, because soil has now remolded. So sensitivity can also be told by torque in undisturbed state to the torque in remolded state. What? Torque in remolded state. And when this happens, sir, we have two values. Question has given us, see, a torque of, see, question में दिया है बहुत easily, एक torque दिया है आपको 600 Nm was required to shear force. The vein shear then rotated rapidly और remolding हो गई 250 पे, तो sensitivity comes out to be 600 by 250. That comes out to be how much? 2.4. Sensitivity is a dimensionless parameter. Always remember. How much is the value? 2.4 only. Value is how much? Please tell me. 2.4? Yeah, Shubham. Yeah, Shubham. Okay. Value is your 2.4. So answer will be what? Answer will be our 2.4. So always remember, in soil, if you know the concept, always it will be easy to answer the questions. There is nothing. See, in this question, maximum data are for no use. He has given just for to play with your feelings, like he is playing with your feelings. In exam you will be in tension, you will be in pressure, you will see we have to use that formula, S is equal to something pi by 4 d by 12. It's not no use. He is just asking about sensitivity, and sensitivity is the ratio of torque in undisturbed state to the torque in remolded state. Okay, we'll move further. This was one of the best question in previous 5 years what HPCL has asked. This is one of the best question I can tell. There are two questions in total, 55 questions. If I will say, there are 2 to 3 questions that are very best question. If you have left this question in the exam also, no problem, because these 2-3 questions are very best question they have framed. But these questions are also from some of the books. If I will tell you, these questions are from which book? Remember, you know, Aurora is a book for soil mechanics, foundation engineering. These are questions same. The means who was the exam setter, he has taken the same questions from there. Just he has changed the value here as a 3. In that book, see, diagram is also same. Diagram is also same. Here, just the value is here as a 3. Their value in question is given as a 2. Nothing has changed. But here one thing is there. In this question, see, there is a one twist. If you first solve, I will tell you what will be the twist. Because see, mostly when you will solve this question, there will be two confusion. First answer you will get very easily, 33.56 very easily you will get. Second confusion will be at point C value is 71.1 or at point C value is 51.32. This will be the most confusing there, what you will take. So okay, let's see. First you try to solve the question. See, Shubham, we can't say on that, but what I have seen up to now, previously, see, if you are preparing for HPCL, one best guidance, just go through PYQs, because every year they are mostly repeating same chapter questions. In soil, if I will tell you, active earth pressure, first chapter sensitivity, they have repeated 2 to 3 times. One is your foundation, their general shear failure SPT test. One is your friction pile, negative skin friction, they have repeated 4 times. So just remember, and if numerical also they are asking now, numerical they are asking on a very basic formula. Here also very basic formula is there. Just one concept is required. Here also not much. I will solve in approximately 20 to 30 seconds. So just go through the basic formulas. Like if I will tell you example, like you have studied discharge, when we will study seepage, discharge through the flow field, we are studying K into H into NF by ND, K into H into shape factor. So they will tell you shape factor is 0.5, tell me the formula. So these are not numericals. These are very small numericals. So always remember the formulas. For HPCL paper, if you are going, remember all the formulas, and that is only where the part you can excel the paper, because time is less. You have to just see the question and tick. Okay. Okay, Shubham. See, the question says at point B and C, these are 2 points. One is your point B, one is your point C. The lateral earth pressure at rest per unit length of the wall, it is giving the unit length is 1. So you don't have to consider, you don't have to multiply. So K naught value, see, always remember when there is a earth pressure at rest, earth pressure, I will do the solution. Whenever there is earth pressure at rest, first meaning, because he can ask you question, earth pressure at rest meaning is your wall is non-yielding, means your wall is not yielding. If your wall is not yielding, earth pressure is at rest. So earth pressure is at rest means what? There is no active or passive earth pressure. So first thing is P naught, first thing is K naught, earth pressure coefficient at rest. What is the formula? So you can know what is the formula is 1 minus sine phi. What is the formula? 1 minus sine phi. See, he has done one thing. He has given you sine 20 and the value of sine 20 0.342. So if I will do 1 minus 0.342, this value comes out to be 0. How much? 342 hai? Approximately 742 minus 0.658. Kitna? 0.658. Clear? So let's calculate first here. See, first I will calculate earth pressure, lateral earth pressure at B point. How lateral earth pressure is calculated? Effective stress times of earth pressure coefficient. This was your lateral earth pressure. Effective stress times earth pressure coefficient. So we will go further at B point. At point B, what is your lateral earth pressure? P naught. Lateral earth. Just give me 1 minute. Lateral earth pressure P naught. That comes out to be K naught gamma into H. K naught, how much? 0.658. Gamma value is your 17 or into 3. That comes out to be 51 into 0.658 into 51. That comes out to be approximately 33.355 kilonewton per meter square. Because it is pressure, so unit is kilonewton per meter square. So first at B it was easy. At B it was what? At B it was easy. What is the value? So see, this is already wrong. C is already wrong. So दो ऑप्शन तो ऐसे ही हट गए, दो ऑप्शन तो यहां से ऐसे ही हट गए, ठीक है ना, दो ऑप्शन तो हमारे ऐसे ही हट गए यहां से. Two options are easily removed from here. If we will move further, now he has asked me earth pressure, tell me at C point. Where? Tell me at C point. Tell me the earth pressure. See, to calculate earth pressure at C point, first I will have to know the vertical stress at C point ना. First I will have to know what? मुझे vertical stress C point पे निकालना पड़ेगा ना, तभी कहीं ना कहीं मैं क्या निकाल पाऊंगा? Lateral earth pressure. So vertical stress at C point. Vertical stress at point C. The vertical stress at point C. How we will calculate vertical stress? Height of soil into its unit width. So here height of soil is how much? Because see, above C, this soil is also there. Don't get confused if you have calculated here, sir, we will not take this, because earth pressure is always earth pressure coefficient time vertical stress. So vertical stress we have to calculate from A up to C. So first vertical stress 17 into 3, no water table, we will consider bulk condition. So for first case, what will be there? 17 into 3. For second, from B to C, this is from where? A to B. From B to C, if you will see, always remember what is there? Water content is there. If water content is there, effective earth pressure, effective stress comes out to be gamma sat minus gamma w. What it comes out to be? Gamma sat minus gamma w. So what will be here? Gamma sat is your 19. Gamma w approximately take 9.81 or 10. I will consider 10, no problem. I will consider 10. Or into height, how much? 3. So this comes out to be 51 plus this comes out to be approximately 9 into 3, 27. So this comes out to be 78 kilonewton per meter square. You see, effective stress, how much? 78 kilonewton per meter square. If your effective stress is 78 kilonewton per meter square, multiply this value with what? Multiply this value with coefficient. So lateral earth pressure P naught, lateral earth pressure P naught, is equal to how much? K naught into 70, and because sigma vertical dash K naught into 78, 0.658 into 78, that comes out to be 51.335, 51 point, how much value? 32 kilonewton per meter square. Understood? 51.32 kilonewton per meter square will be your answer. Okay, Shubham? Clear? 51.32. One thing remember, सर ये 72 क्यों दिख रहा है? अब पॉसिबिलिटी है बिकॉज जिस टेक्स्ट बुक से ये क्वेश्चन उठाया है उन्होंने लैटरल अर्थ प्रेशर मेंशन किया, बट यहीं पे अगर मैं आपसे बोलता हॉरिजॉन्टल लैटरल अर्थ प्रेशर, तो कहीं ना कहीं आपके पास आपको इस वाटर का यूनिट वेट इनटू हाइट भी ऐड करना पड़ता. आपको क्या ऐड करना पड़ता? You have to add water unit weight of water into, because that will also exert. So if you would have asked you total horizontal pressure, if he have asked you P naught, don't, if you had asked you pH horizontal pressure total pH, then you have to add gamma WH. So here the answers comes out to be what? Answer comes out to be D. Answer comes out to be D. Clear? Can we move further? Okay. Okay, just tell me what will be the answer. Sinking of zone 1 shown in the figure, which represent general shear failure assumed at Terzaghi for a strip footing. Okay, he is asking you ki zone 1, zone 2 or zone 3. I have always told you, always study foundation engineering, because one of the most important topic, HPCL is asking every time 2 to 3 questions in every paper. So he is asking about zone 2 and zone 3. So always you remember zone 2 is a radial shear zone and zone 3 is a passive Rankine zone at zone 3. So what is your zone? What is your zone 2? Zone 2 is what? Zone 2 is your radial shear zone. Zone 3 is not radial. So zone 2 is your radial shear zone and passive Rankine zone at 3. Passive Rankine zone at 3. Okay. See the answer. Radial shear zone at zone 2 and passive Rankine zone at zone 3. So explanation is also given here. You can go through it and pause and go through it. Okay. What is asking? What is the Rankine's active earth pressure against the wall with a smooth vertical back 10 meter high supports a purely cohesive soil with C. So now he has changed the condition. He is asking you active earth pressure now in case of cohesive soil. So if you remember active earth pressure in case of cohesive soil, PA in cohesive soil, what was your formula? The formula comes out to be PA is equal to gamma, sorry, K, first is your K, Ka gamma into H minus 2C under root Ka. This was your formula. This was your formula. What? Ka gamma into H minus 2C under root Ka. Now, we don't have the formula for K, but we know K is equal to what? 1 minus sin phi upon 1 plus sin phi. 1 minus sin phi upon 1 plus sin phi. See, in question, he is given you pure cohesive soil. Pure cohesive soil means angle of internal friction. What? Angle of internal friction comes out to be 0. Angle of internal friction comes out to be 0. Then this value 1 minus sin 0 divided by 1 plus sin 0. Then this value comes out to be 1. Then this value comes out to be 1. K 1 है तो PA आपके पास क्या हो गया? PA हो गया सर K1 gamma. How much he has given you? He has given you how much? 17.66. 17.66 into 10 minus how much? C value. Minus C value is how much? Twice of C. 2 into C. 2 into 9.81. 2 into 9.81. अब एक चीज ध्यान दीजिएगा, अब आप इसको कैलकुलेट करने जाओगे, then if you are going to calculate this, you are a stupid kind of student, because see all the three options. See what will come? 10 into 17.66, approximately 170. 170 minus 10, approximately what value? Approximately 156 na. So we don't have to solve directly. What we can say, approximately your value will be 156 kilonewton per meter square. See, sorry, pressure, what here asked you, Rankine active earth pressure, 156.98 kilonewton per meter square. It would be Rankine active earth pressure, it would be 156.98 kilonewton per meter square. Okay, can we move further? Okay, चलो बताइएगा जितने भी लोग लाइव हैं, all the people who are live, please tell me up to here clear. See, this question is repeated one more time also. A clay has a dry density of 1.85 gram per centimeter cube G value. We have calculated here. What your shrinkage limit? 17.16%. We have calculated above also. What is the shrinkage limit? 17.16. Okay. Can we move further? Tell me, which of the following statement in the context of capillary pressure is what? Is not true. He is asking you which of the statement in context of capillary pressure. Tell me कौन सा इसमें से statement है in context of capillary pressure which is not true. You always know capillary pressure is more in coarse grained soil. This is always false. This is always, because capillary pressure is not more in coarse grained soil. So this is always false. Answers comes out to be A. Answers comes out to be A. See, capillary pressure is inversely proportional to the pore size of the soil. So how much big will be the pore size? Capillary pressure will be less. Okay. According to particle size distribution curve, if the value of coefficient of uniformity Cu is greater than 6, what he is telling you, Cu की value greater than 6 है और Cc is between 1 to 3, Cc is between 1 to 3. In that case, the value tells about well graded sand, because Cu 6 से ऊपर हुआ, it is always well graded for well graded sand, because if these two values qualify, it is always what? It is always well graded sand. If these two value qualifies, it is always well graded sand. If Cu is less than 6, if Cc is not lying between 1 to 3, then you can say poorly graded. But he is telling you what? He is telling you value is what? C, well graded sand. See, well graded sand is your answer. Cu greater than 6, Cc is 1 to 3. What is the free fall height of hammer in standard? I told you na, from foundation they have asked number of questions. What is the free fall height of the hammer in a standard penetration test? In standard penetration test, free height of hammer is 75 centimeter. Okay. In standard penetration test, free fall height is how much? 75 centimeter. In standard penetration test, a hammer weight of 63.5 kg is allowed to fall from a height of 75 centimeter. Okay. Can we move further? In particle size, a steep grain size distribution curve. If particle size, if you have a steep grain size, I told you, steep curve means poorly graded or uniform. If it is somewhat less steep, you can say poorly. If it is fully steep, means only one size particle is available in that. That is known as more uniform grain size. What is known as more uniform grain size? Okay. See, answer is there. A steep grain size distribution curve indicates that most soil particles lie within a narrow size range. Okay. The width of the test pit for a plate load test. For a plate load test, when you are going to do a plate load test, the width of the test pit was, you remember, should not be less than 5 times of the width of the plate. When you are going to do a plate load test, in that you will excavate a pit as how your foundation is there. So in that, how much is the width of foundation? That much should be the width of your pit. And if you are using as a plate, then the plate width pit width should not be less than 5 times of plate width. So answer will be what? Answer will be 5 times the width of the plate. Moving further, see here you can see correct answer is your 5 times the width of the plate. Okay, आगे चलते हैं. For a dense sandy soil, what I have told you, SPT is one of the favorite topics of HPCL. He has asked you for a dense sandy soil, the value of N, SPT number value for a dense sandy soil. As per the denseness of soil was increasing, SPT number was increasing. For very dense, greater than 50. For dense sandy soil, the value was 31 to 50. Always remember, for dense sandy soil, the value comes out to be 31 to 50. Okay, can we move further? चलिए आगे लेके चलते हैं आपको. Can we move further? See, the value comes out to be for very dense, how much? 50 से above. Very loose, less than 4. Loose 4 to 10. Medium is your 10 to 30. The phenomenon of strength loss, strength gain with no change in volume of water content is known as. What was that phenomenon? Can you please tell me? Means strength loss and strength gain. Thixotropy? Sensitivity is just the loss of strength. Thixotropy is regain value. Sensitivity is what? Sensitivity is the loss of strength on remolding. He has told you the phenomenon. See, it will lose the strength, then it will gain, but it will not go to original value. Then after that, if remolding is there, then it will lose. Then it will also gain. So what he is telling, the phenomenon of strength loss and strength gain with no change in volume is known as thixotropy. Is known as thixotropy. See, thixotropy is the property by which a remolded clay loses strength initially and then regains a part of with time without change in water content. Clay having a sensitivity greater than 16, what is it told as? If your clay is having a sensitivity value greater than 16, please tell me, what will be the answer? What will be the answer? If clay is having a sensitivity value greater than 16, quick clay, because if value is less than 1, it was insensitive like kaolinite. If value is more, then extra sensitive. If value is greater than 16, then what was there? Quick clay. Then what was there? Quick clay. Understood? See, a quick clay sensitivity is the ratio of undisturbed strength to the remolded strength. If the sensitivity value is greater than 16, the clay is termed as quick clay. Always remember the clay is termed as quick clay. 29. Lime stabilization is very effective in treating. Always remember, lime stabilization is one of the technique to stabilize your soil, loose soil, where strength is very less. So in lime stabilization, generally you will use for plastic clay soil. In plastic clay soil, you will add lime to stabilize, means to increase the strength of soil, so more loading can be applied on the soil. So your answer will be plastic clay soil. Your answer will be what? In lime stabilization is very effective in treating plastic clay soil. Moving further, see, plastic clay soil is there. Lime stabilization is especially effective for plastic clay soil because lime reduces plasticity and improves strength and workability. Okay. The area ratio for soft sensitive clay. Remember, area ratio, sampler, outer dia, inner dia. We would find outer dia, inner dia. There is also one formula for area ratio. See, these are all the values they are going to ask you. You will always remember what you will say, sir, these chapters are not important, but they are going to ask from there only. So always remember, always study soil exploration chapter. Always soil exploration chapter, always study, because they will ask you very number of questions like soil stabilization, like geonets, like geogrids. These are all the questions they are going to ask you. So always study this. What he is telling, area ratio for soft sensitive clay. For soft sensitive clay, always remember area ratio is less than 10%. If he is telling you hard stiff clay, the value comes out to be 20% less than. But if he is telling you soft sensitive, the value comes out to be less than 10%. C, answer is your C. Less than 10% for obtaining undisturbed sample in soft sensitive clay. The area ratio of sampler should be as small as possible. Okay. According to IS classification system, the plasticity falls above A line. If your plasticity is falling above A line, always you have remember, this was your Casagrandes chart, Casagrandes graph, yeah, Atterbuck's graph. You would tell here what? Here was your plasticity index IP. Here was your liquid limit WL, or water content. You can say here is your water content. Here is your water content. This graph was what? This graph was for check the soil is clayey or not. So there was like this one, A line was there, A line was there, A line equation, A line equation, IP is equal to, A line का इक्वेशन क्या था मेरे भाई? IP is equal to W.73 WL minus 20. So A line above A line clay, below A line silt, below A line silt. सेम हियर, वैल्यू कहां तक थी? 35 to 50 और 50 से ऊपर. So here what he is asking, according to IS classification system, plasticity chart that falls above A line. Above A line, it is your clay, and liquid limit is your 40. Liquid limit is 40 means 35 to 50. It is your intermediate compressibility. What is that? Intermediate compressibility. So solution comes out to be CI. So solution comes out to be CI. Okay. CI is what? Clay with intermediate compressibility. Intermediate compressibility. Okay, moving further. CI देखो आंसर है. मैकेनिकल स्टेबलाइजेशन का मतलब क्या होता है? मैकेनिकल स्टेबलाइजेशन मतलब दो सॉइल्स को ऐड करना, दैट इज नोन एज मैकेनिकल स्टेबलाइजेशन. सो मैकेनिकल स्टेबलाइजेशन मीनिंग मिक्सिंग ऑफ टू और मोर टाइप्स. क्योंकि देखो, एडिशन ऑफ केमिकल्स, इट इज केमिकल स्टेबलाइजेशन. एडिशन ऑफ लाइम इज आल्सो केमिकल. एडिशन ऑफ सीमेंटिंग मटेरियल, इट इज आल्सो केमिकल स्टेबलाइजेशन. So when he will ask you about mechanical stabilization, the answer comes out to be what? The answer comes out to be mixing of two or more types of natural soil. Same चीज है, answers. Okay, undisturbed soil samples are required. Soil exploration, many number of questions they have asked. They have asked many number of questions from soil exploration. What he is telling, undisturbed soil samples are required for. He is asking you, undisturbed soil samples are generally required for consolidation test, because for consolidation test you will always require undisturbed soil sample. If there is disturbance in the soil sample, your consolidation test results will not be as accurate. But see, for other option, specific gravity test, there will be some disturb, no problem. For shrinkage also, disturbance is there, no problem. But for undisturbed soil sample, always for what? Consolidation test. Always remember. Okay. So consolidation test and undisturbed sample preserve the natural structure, water content. Why? What is this? See, what is meaning of undisturbed and disturbed sample? Undisturbed sample means your sample, nothing is changing. No soil structure, no its property. If disturbed sample, in disturbed also two cases are there. Some properties are changing, some are not changing. Non-representative sample, representative sample. We are going to define like that. So for consolidation test, what we are going to do? For consolidation test, we are going to do which? We are going to do undisturbed soil samples. Moving further. See, cohesive soil yields a maximum dry density of 1.8 gram per cc during standard Proctor. If the specific gravity 2.65, what would be its void ratio? Tell me, void ratio. Tell me, what will be its void ratio? Find out. Dry density, always remember when you are studying standard Proctor test, what was formula? G rho W upon 1 plus E. This was your formula we can use. G rho W upon 1 plus E. Yes. Yeah, you can use W into G also, because SE is equal to WG. You can use that also. So here is what? 1.8 is equal to G. G value is what? G value given 2.65 into gram per cc 1 divided by 1 plus E. From here we can find out E. E is what? 0.47, because see, what will be the 2.65 minus 1.8 divided by what? 1.8. So what will be answer? 0.472. Answer will be what? E is equal to 0.472. E will be equal to 0.472. Clear? Okay. Can we move further? So E value is equal to what? 0.472. From here we can determine. Moving further. See, this is also important question they can ask you. Safe bearing capacity of coarse sand, compact and dry according to NBCI, National Building Code. There is one code available. With their code, they have given the different values of bearing capacity for different types of soil. If he will ask you about, always remember coarse sand, compact and dry, always remember the value comes out to be 440 kilonewton per meter square. For dry, compact, coarse sand, the value comes out to be how much? The value comes out to be 440 kilonewton per meter square. Always remember. According to NBCI, the presumptive safe bearing capacity of coarse sand in compact and dry condition is your 440 kilonewton per meter square. Always remember this. Okay. In sieve analysis, the proportion of soil sample retained on plus 4.75 mm size is termed as what is known as retained on plus 4.75. If retained, he is asking, he is not asking passing. If retained is there, means the fraction is gravel fraction. Which fraction is there? Gravel fraction, because he is asking you about retained. So if he is asking about retained, then fraction is gravel fraction. See, answer is your gravel fraction. In pile foundation, the negative skin friction, I told you na, he will ask many questions from pile foundation, shallow foundation. In pile foundation, he is telling negative skin friction. Negative skin friction when occurs? When respect to pile, when your soil is moving downward, in that case, the friction you will be seeing will be negative skin friction. See, generally what happens in normal cases, when you are driving a pile, with respect to soil, pile should go below. What is happening? With respect to soil, pile should go below. If pile is going below, friction will act upward. Then if friction is acting upward, we are getting resistance for the load in downward direction. But what is happening? If soil is loose, when you will drive the pile, with respect to pile, now soil is going down. Because with respect, because how much pile is driving, In that respect, soil is more settling. With respect to pile, soil is going more down. If soil is going more down, what will happen? With respect to soil, see, pile is going up, friction will act in downward direction. Because of that, your ultimate load carrying capacity of pile will decrease. Ultimate load carrying capacity of pile will decrease. So in pile foundation, the negative skin friction is developed by downward movement of soil. How it will develop? Downward movement of soil. Okay. See, downward movement of soil. Negative skin friction develops when surrounding soil settles downward relative to the pile. Okay. Can we move further? See, this is also a good question. See, same negative skin friction. In 1 year, see what HPCL is doing. They are taking a certain topic. See, in 23, 24, this question. There they have taken negative skin friction. They have asked 4 questions. If they are taking your first topic like index property, they are asking 3-4 questions. If they are taking capillary, they are asking 3-4 questions. Like this, their pattern is there. Okay. See, what will be here answer? Which of the following statement is correct regarding negative skin friction? Now, अभी मैंने आपको बताया था negative skin friction is downward drag acting on a pile due to downward movement of surrounding compressible soil. Same, clear है? Because down direction में आपका friction लग रहा होगा because of what? Because of surrounding compressible soil is settling. Second, read. The magnitude of negative skin friction for granular soil is P into C into LF. नहीं. This is for cohesive soil. Alpha into C into pi d L. You study skin friction for cohesive soil. Alpha into C into pi into d into L area. But here this is for cohesive soil. For granular soil, we would take earth pressure, average earth pressure. From there, we would find the value. So here what? The magnitude of negative skin friction for granular. No, this is not for granular. This is for cohesive. This is for cohesive. So what will be? Your B will be wrong. Answer will be what? Only 1. Answer will be what? Only 1. See. Statement 2 is incorrect because expression P into C into LF applies to cohesive soil, not granular soil. Okay. See this question. What he is telling, a cylinder of soil fails under axial vertical stress of 140 kilonewton per meter square. When it's laterally confined, the failure plane makes angle 45. What is the horizontal? See, कौन सा test है? Unconfined compression test. See, always remember, unconfined compression test is there. Means जो confined pressure or cell pressure stage, sigma 3 comes out to be what? Sigma 3 comes out to be 0. Sigma 3 comes out to be 0 because unconfined pressure है ही नहीं, cell pressure. Remember one formula, sigma 1 is equal to, you have formula, sigma 1 is equal to sigma 3 tan square 45 plus 5 by 2 plus 2c tan 45 plus 5 by 2. Here see, failure plane makes kitna angle? 45. So failure plane theta is equal to 45 plus 5 by 2. From there you will get the value of phi. Phi value what? 0. From if you will calculate from there phi value, see, failure plane is making theta is equal to how much? 45 plus 5 by 2. If I want to calculate phi value, theta how much? 45. Failure plane is at 45 is equal to 45 degree plus 5 by 2. Phi comes out to be 0 degree. Phi comes out to be 0 means the case is of pure clay. The case is of pure clay. In pure clay, remember cohesion value. What he has asked you? Cohesion value is how much time? Half times of vertical stress. Sigma जो main sigma 1 जो self deviator stage, from deviator stage we will find out sigma 1. Sigma 1 is meant as for failure, where failure will occur. Sigma 1 is equal to sigma 3 plus sigma d. So major principal stress sigma 1, and for unconfined compression test, if clay is there, the cohesion comes out to be sigma u divided by 2. Remember, from here we can say cohesion comes out to be how much? Sigma vertical u divided by 2. So sigma u value is how much? 140 divided by 2. It will be 70 kilonewton per meter square. Understood? How much will be the value? 70 kilonewton per meter, because it is this test, unconfined compressive test. If you will see that test also, there directly we have one value, and one value is what? One value we will get directly. Cohesion is equal to, undrained cohesion is equal to your major principal stress sigma 1 value divided by 2. You will get that value directly. Okay, there are two stages, always remember. One is your cell pressure stage, one is your deviator stage. In cell pressure stage the value is sigma 3, cell pressure, and deviator stage you will apply sigma d, and if you will want sigma 1 is your major principal stress, that sigma 1 will be how much? Sigma 3 plus sigma d. Okay, so from here you will get the answer as 70 kilonewton per meter square. Can we move further? Sedimentation analysis is used when the soil fraction is finer than. When you will use sedimentation analysis? Sedimentation analysis mainly will be used when soil fraction is finer than 75 micron, means less than sand. When you have fine grained soil like silt and clay, there you will use what? There you will use sedimentation analysis. And if soil is very fine, then there we will not use these analysis. Their analysis will be different then. Okay, their analysis will be different. Okay, 75 micron size. Moving further. See, in context of, then now also standard penetration. Standard penetration is one of the most favorite topic of HPCL, I think so. In standard penetration text के context में during overburden, N naught is the actual value of penetration resistance, N naught is the corrected value, N naught is the corrected value. The answers comes out to be what? Remember, PEC. From the PEC's formula, N naught is equal to C into N. N naught is equal to C into N. From the PEC's formula, you are analyzing N naught is equal to Cn into N. Remember? See, in standard penetration test, blow count N is corrected for overburden correction factor Cn. Then formula is N naught is equal to Cn into N. Okay, ठीक है. Okay, ये बताइएगा. In the context of soil classification system, what is the A-line equation from the Casagrande? What is the A-line equation from the Casagrande? In the soil classification system, what is the A-line equation in Casagrande? 0.73 WL minus 20. What is the equation? 0.73 WL minus 20. शुभम जहाँ CN की वैल्यू जनरली वो आपसे नहीं पूछना चाहेगा, बहुत लेस चांसेस है. अगर पूछा है तो आप पढ़ सकते हो उसको, आपको नोट्स में मिल जाएंगे, उसको पढ़ लीजिएगा. IP is equal to 0.73 WL minus 20. सी वही है. ये सब बहुत बेसिक क्वेश्चन है, तो इस पे समय खर्च करने का मतलब नहीं बनता है. The consolidation test data is used to determine which of the following properties of soil. कंसोलिडेशन टेस्ट डाटा से आप कौन सी प्रॉपर्टी निकाल सकते हो? तो मुझे दिख रहा है बियरिंग कैपेसिटी नहीं मिलती है, बट हाँ कंसोलिडेशन टेस्ट से हम के निकाल सकते थे. याद है कोएफिशिएंट ऑफ कंसोलिडेशन में के का वैल्यू आता है, उस के को आप वहां से चाहो तो डिटरमाइन कर सकते थे. क्योंकि जब परमेबिलिटी भी हम पढ़ते हैं तो कोएफिशिएंट ऑफ कंसोलिडेशन का एक फॉर्मूला होता है जिससे आप क्या निकाल सकते हो? जिससे आप परमेबिलिटी निकाल सकते हो. सो ये और ये दोनों निकाल सकते हैं. सो आंसर कम्स आउट टू बी ओनली 1 and 2. सो आंसर कम्स आउट टू बी ओनली 1 and 2. ठीक है, क्या है? ओनली 1 and 2 है. चलिए बताइएगा, विच ऑफ द फॉलोइंग मेथड इज यूज्ड टू डिटरमाइन के इज इक्वल टू सीवी एमबी गामा डब्ल्यू? बिल्कुल. विच ऑफ द फॉलोइंग मेथड इज यूज्ड टू डिटरमाइन द इन सीटू डेंसिटी? इन सीटू डेंसिटी किससे? सैंड रिप्लेसमेंट से भी मिल जाता था, कोर कटर से भी मिल जाता था. तो आपका बोथ 1 and 2. तो बोथ 1 and 2 आपको सैंड इन सीटू मतलब फील्ड वाली होती है. फील्ड वाली आपको सैंड रिप्लेसमेंट से भी मिल जाता था और दूसरा आपको कोर कटर से भी मिल जाता था. तो दोनों से ही आप चाहो तो निकाल सकते हो. ठीक है. सबसे फास्टेस्ट टेस्ट कौन सा होता है वाटर कंटेंट को निकालने के लिए? कभी इफ ही हैव आस्क्ड यू इन जनरल केसेस व्हिच ऑफ द फॉलोइंग इज द फास्टेस्ट मेथड टू डिटरमाइन वाटर कंटेंट? कैल्शियम कार्बाइड. याद रखिएगा, देयर ही कैन आस्क यू मेनी डिफरेंट टाइप्स ऑफ क्वेश्चन. व्हिच ऑफ द फॉलोइंग इज एक्यूरेट मेथड? ओवन ड्राइंग. ओवन ड्राइंग इज वन ऑफ द एक्यूरेट मेथड. सो आंसर है बोथ 1 and 2. ओके ओके. कीजिएगा सॉल्व. A compacted fill is to be constructed. The soil is taken from two areas. एक एरिया ए है, एक एरिया बी है. अगर उससे मैंने कॉम्पैक्टेड फिल बनाया तो पूछ रहा है मुझे रेशियो बता दीजिए कितना होगा दोनों सॉइल के वॉल्यूम का. ऐसे केसेस में जनरली कभी भी याद रखिएगा, ये भी क्वेश्चन जो है एक टेक्स्ट बुक का ही क्वेश्चन है. अगर मैं आपसे बोलूं के आर अरोरा, उसके क्वेश्चन भी आप देख के चले जाओगे तो एचपीसीएल में आधे काम आपके हो जाएंगे. तो वही का ये क्वेश्चन है, उसमें बेस्ट बेसिकली आंसर्स कम्स आउट टू बी 9:8 है. कैसे बनेगा देखो, मैं क्या करूंगा सॉल्यूशन में, मैं सॉल्यूशन में निकाल लूंगा. सबसे पहले सॉइल ए का मैं ड्राई डेंसिटी निकाल लेता हूं. देखो ड्राई डेंसिटी आप लोग को जनरली पता है क्या होता था? जी गामा डब्ल्यू अपॉन 1 प्लस ई. ड्राई डेंसिटी किसी भी सॉइल की क्या होती थी? जी गामा डब्ल्यू अपॉन 1 प्लस ई यूज कर सकते थे. तो सॉइल ए की ड्राई डेंसिटी निकालोगे तो जी कितना दिया है? जी दिया है 2.65. गामा डब्ल्यू है 9.81 यूज कर लीजिए. 9.81 डिवाइडेड बाय 1 प्लस 0.8. तो जरा ये बता दीजिएगा ये वैल्यू कितनी आ रही है. आई होप ये वैल्यू आपको आएगी 14.42 समथिंग. एक बार बताइएगा 14.44 समथिंग, 442 किलो न्यूटन पर मीटर क्यूब. यही आ रही है क्या? एक बार बताइएगा. जस्ट प्लीज टेल मी वंस, यही वैल्यू आ रही है क्या? दिस इज योर शुभम झा. दिस इज योर PYQ क्वेश्चंस ऑफ ऑल द ऑफिसर लेवल पेपर ऑफ लास्ट 5 years of HPCL for soil. Tomorrow I will bring some practice questions and JEO level questions. tomorrow there will be some practice questions also. This is all your PYQ question. नहीं 2.65 into 9.81 by 1.8 नहीं, possibilities नहीं. So 2.65 into 9.81 by 1.8, it will be approximately 14.442. हाँ, वैल्यू इज करेक्ट. सी सॉइल ए ये हो गया. अब एक बात बताओ, सॉइल बी, सॉइल बी में ड्राई डेंसिटी आई कैन डिटरमाइन. ड्राई डेंसिटी सॉइल बी क्या लिखेंगे, जी गामा डब्ल्यू अपॉन 1 प्लस ई इज इक्वल टू हाउ मच, 2.65 इंटू 9.81 डिवाइडेड बाय 1 प्लस 0.6, और 1 प्लस 0.6 अगर मैं कर दूं तो ये वैल्यू आ जाएगा 16.24 किलो न्यूटन मीटर क्यूब. अब एक चीज ध्यान देना, अभी आपने क्या निकाला, अभी आपने दोनों की ड्राई डेंसिटी निकाली. क्वेश्चन में बोला है कि इन दोनों सॉइल से मैं एक कॉम्पैक्शन फिल बनाने वाला हूं जिसका वॉल्यूम 50,000 मीटर क्यूब है. एक काम करते हैं ना, 50,000 छोड़ते हैं, 1 मीटर क्यूब के लिए चेक कर लेते हैं. अगर मैं यहाँ पे वॉल्यूम 1 मीटर क्यूब ले लूं, अगर मैं वॉल्यूम 1 मीटर क्यूब ले लूं तो वेट ऑफ ड्राई सॉइल कितना हो जाएगा, 14.442. अगर मेरे पास वॉल्यूम देखो, मेरे पास वॉल्यूम, if volume is 1 meter cube, weight of dry soil, weight of dry soil, क्योंकि देखो मैं ड्राई के टर्म्स में क्यों बात कर रहा हूं, सॉलिड्स के टर्म में सारी चीजें चलेगी. वेट ऑफ ड्राई सॉइल ए तो क्या हो जाएगा 14.442 किलो न्यूटन, एंड वॉल्यूम इज 1 मीटर क्यूब, वेट ऑफ ड्राई सॉइल बी, वेट ऑफ ड्राई सॉइल बी कितना हो जाएगा 16.24 किलो न्यूटन. बिल्कुल. अब एक बात बताओ, ये जो फिल आपने किया, द कॉम्पैक्टेड फिल किया, इसका वाटर कंटेंट और यूनिट वेट पता है, इसकी भी ड्राई डेंसिटी आ जाएगी, बल्क यूनिट वेट अपॉन 1 प्लस वाटर कंटेंट. जो कॉम्पैक्शन फिल आपने किया, तो आप देखो, आपने देखो ड्राई डेंसिटी ऑफ कॉम्पैक्टेड फिल, ड्राई यूनिट वेट ऑफ कॉम्पैक्टेड फिल. तो अगर कॉम्पैक्टेड फिल का ड्राई यूनिट वेट देखे तो क्या हो जाएगा, बल्क यूनिट वेट अपॉन 1 प्लस वाटर कंटेंट. बल्क यूनिट वेट 20 दिया है, वाटर कंटेंट है कितना 0.2, दिस वैल्यू कम्स आउट टू बी 20 डिवाइडेड बाय 1.2, 16.66 किलो न्यूटन पर मीटर क्यूब. ठीक है. अब एक बात बताओ, इसकी भी 1 मीटर क्यूब का वेट कितना हुआ ड्राई के लिए, 1 मीटर क्यूब का वेट कितना हुआ, 1 मीटर क्यूब वेट, नहीं क्या ये लिखेंगे ना, क्या लिख रहे थे हम लोग, वॉल्यूम ना, वॉल्यूम, वॉल्यूम के टर्म से, वॉल्यूम इज 1 मीटर क्यूब, वॉल्यूम इज 1 मीटर क्यूब, वेट ऑफ ड्राई सॉइल, वेट ऑफ ड्राई सॉइल कितना हो जाएगा, वेट ऑफ ड्राई सॉइल कितना हो जाएगा 16.66 किलो न्यूटन हो जाएगा. अब एक चीज सोचो, अगर आपको तीनों का वेट मिल गया 1-1 मीटर क्यूब के लिए, तो अगर मुझे आपसे पूछना हो कि मुझे सॉइल ए का वॉल्यूम बताओ, तो आप क्या बोलोगे, 16.66 टोटल वेट है, उसमें से सॉइल ए का कंट्रीब्यूशन कितने का है 14.42 का, बी का कंट्रीब्यूशन निकाल लोगे, तो यहां से आपको वॉल्यूम किसके लिए मिल गई, ए के लिए मिल गई 1 मीटर क्यूब के लिए, वॉल्यूम किसके लिए, बी के लिए. यही तो रेशियो पूछा है क्वेश्चन में. क्या पूछा है देखो, द रेशियो ऑफ सॉइल टू बी एक्सकवेटेड फ्रॉम एरिया ए एंड टू दैट ऑफ एरिया बी. सो if I want volume of soil from area A, वो कितना हो जाएगा, आपके पास कितना है, टोटल कितना है आपके पास फिल का 16.66, उस 16.666 को डिवाइड कर दो किससे, 14.442 से, 14.442 कितना आ गया 1.15. और ऐसे ही वॉल्यूम ऑफ सॉइल फ्रॉम बी, वॉल्यूम ऑफ सॉइल फ्रॉम एरिया बी, वॉल्यूम ऑफ सॉइल फ्रॉम एरिया बी क्या आ जाएगा 16.66 डिवाइडेड बाय 16.24 कितना आ गया 1.02. आपको इन्हीं दोनों का रेशियो तो पूछा है, तो रेशियो किसका है, रेशियो ऑफ वॉल्यूम ऑफ एरिया ए टू एरिया बी, एरिया ए टू एरिया बी, एरिया ए टू एरिया बी कितना आ गया 1.15 डिवाइडेड बाय 1.02 कितना आ रहा है ये 1.12 या 13 के आसपास. जो अप्रोक्सीमेटली 9/8 की भी वैल्यू होती है। 9/8 देखो, 9/8 भी आपको 1.15, क्योंकि 3-4 वैल्यू आगे तक लेके जाओगे तो उसी के आसपास आपको देखने को मिल जाएगा। 3-4 वैल्यू आगे ले जाओगे तो उसी के अप्रोक्सीमेटली व्हेन यू विल गो 3 or 4 वैल्यूज फर्दर, द वैल्यूज कम्स आउट टू बी दिस ओनली 1.15:1.02. Yeah, from there if you will determine how much is the ratio comes out to be 9:8. Ratio comes out to be 9:8. ठीक है। Simply one thing you can also think, if you will think this question in another way. एक चीज मैं सोच सकता हूं, क्या सोच सकता हूं, देखो एक बात बताओ आपको, यू नो ना फॉर्मूला, वॉल्यूम ऑफ सॉलिड क्या होता था? वॉल्यूम ऑफ सॉलिड क्या होता था? टोटल वॉल्यूम अपॉन 1 प्लस वॉइड रेशो। टोटल वॉल्यूम अपॉन 1 प्लस वॉइड रेशो। टोटल वॉल्यूम अपॉन 1 प्लस वॉइड रेशो। अगर इसके लिए देखोगे तो इसके लिए अब देखो, वॉल्यूम ऑफ सॉलिड ए प्लस वॉल्यूम ऑफ सॉलिड बी क्या मिलेगा? वॉल्यूम ऑफ कॉम्पैक्टेड सॉलिड मिल जाएगा। वॉल्यूम ऑफ सॉलिड ए, वॉल्यूम ऑफ सॉलिड ए में इसका कंट्रीब्यूशन कितने का है? 1.8 का है। इसका कंट्रीब्यूशन कितने का है? 1.6 का। तो 1.8 बाय 1.6 भी करोगे तो अप्रोक्सीमेटली आपको क्या मिलेगा? 9/8 ही मिलेगा। तो देखो ये तो मैंने आपको सॉल्व करके दे दिया, जो आपका नॉर्मल मेथड है। हियर आई हैव सॉल्व्ड व्हाट इज योर नॉर्मल मेथड सेज, बट इफ यू विल मेक सम अंडरस्टैंडिंग, सी you know volume of solid of A plus volume of solid of B will be equal to total volume. किसका? solid of compacted fill. So volume of solid A, it will be in a ratio of 1.8, because here 1 plus 0.6, 0.8, and second one will be the ratio of what? It will be 1.6. Means its contribution 1.8, its contribution 1.6. If you will try to balance the ratio, it comes out to be 9:8. If you try to balance the ratio, it comes out to be 9:8. Yeah, you can use for borrow pit also. If he have asked you number of trucks, you can use for that also. If he has asked you which of the following is economical for us, for that also you can use. You can use for many things. So this comes out to be your answer. Understood? Okay. Can we move further? See, the result of standard Proctor test provide. What will be the provided from result of standard Proctor test? Optimum moisture content and maximum dry density. When you will do standard Proctor test, SPT, standard Proctor, not penetration, standard Proctor test is done to find what? Optimum dry density and what? Optimum dry density and maximum dry density and optimum moisture content. Okay, Shubham, right? Tell me, if the retaining wall is restrained against yielding, the earth pressure developed on the wall. If your retaining wall is restrained against yielding, the earth pressure developed will be what? Earth pressure will be developed zero earth pressure. Sorry, earth pressure at rest. Sorry. Earth pressure at rest. What will be what? Your wall is against yielding. Restrained means it is not yielding. Then what will be your earth pressure developed? It will be earth pressure at rest. Moving further. The most suitable compacting equipment for core of earthen dam, sheep foot roller. Remember, sheep foot roller. Always you will be given one table. In table, different instruments where you will use that instrument. Which action will be there? Like pressure action, kneading action, which action will be there? There one table will be provided by your faculty. Always read that. The most suitable compacting equipment for core of earthen dam, sheep foot rollers. Understood? See. Sheep foot roller, the core of earthen dam is usually made of cohesive soil, which requires kneading action and proper compaction. So what will be the answer? Sheep foot rollers. See, for a flow through a soil permeability K under head H, the shape factor. What is your formula for seepage? Seepage is equal to K into H into NF by ND. Number of flow channels by number of equipotential drop. So this is also known as shape factor. This is also known as what? Shape factor. If this is known as shape factor, what will be the formula? KH. Here he has told you shape factor is 0.5. Shape factor is 0.5. The formula comes out to be Q is equal to 0.5 KH. क्या आ जाएगा formula? 0.5 KH. Understood? Okay. Can we move further? See. The dash is based on Coulomb's theory for determination of active earth pressure on soil with no cohesion. See, Jumikis and Janbu's method generally we don't use. Casagrande curve fitting is for consolidation. When secondary we are doing for consolidation. Skempton's graphical not. It's Kuhlmann's graphical method. Kuhlmann's graphical method is used in place of Coulomb's theory for determination of active earth pressure on soil. So always remember they can ask this also. So what you have to do when you will study active earth pressure and stability of slope, always remember the names of the scientist who has given this formula, who has applied the modification, because they will always ask you. So here, what is the method? It's Kuhlmann's graphical method. See, Skempton's graphical method, Casegrande's curve fitting method, it is mostly used where? It is mostly used in consolidation. Okay, can we move further? See, we have came to 51st question. What is 51st question saying? A group of 9 pile 10 meter long 350 mm in diameter is to be arranged in a square pattern in a cohesion C. Find the center to center spacing of pile for a group efficiency 1. See what he has given you. He has told you this is your group of pile, 9 pile group. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 piles are there. He has told you, tell me center to center spacing. He is asking you this value S. See, I remember always one formula. Efficiency of pile group is equal to what? Ultimate load carrying capacity by group into N into individual pile capacity. He has told you to consider efficiency value as 1. He has told you to consider efficiency as 1. But individual pile, when we are calculating capacity for cohesive soil, value is alpha C into pi dl, because surface area into length, surface area is your circumference, pi d into L will give you surface area. So here comes out value alpha, we will consider 1. Cohesion is given in the question, how much? 60 into pi we don't know, pi sorry we know pi we know. D is 350 mm, some values are in meter, so always remember this will be 0.35 and this will be what? It will be 10. So this will get 659.4 kilonewton. 659.4 kilonewton only, because हाँ ये आपका मीटर स्क्वायर में होगा. And all the piles, how much piles are there? Total 9 piles. So total load carrying capacity of individual piles, total load carrying capacity of individual piles. Capacity of individual piles. So total load carrying capacity of individual piles comes out to be 9 into 659.4. How much? 593.6 kilonewton. This is your total load carrying capacity of all the individual pile. अब हम ग्रुप का निकालेंगे. So load carrying capacity of pile group, load carrying capacity of pile group, carrying capacity of pile group. Now remember one thing, generally students go wrong here only, that is QUG. See, if we are calculating load carrying capacity of this whole pile, so what it will be? See, I have to calculate this B, because this is your square pile. So if you will take surface area will be perimeter. What will be your surface area? 4 times of B, but we don't know here na B. So how we will calculate B? Remember, always you know one formula, M minus 1 into S plus D. See, this is your center to center spacing. If see, this is 3 by 3 pile, how many S you will take? 1S plus 1S. Either half D, either half D. So we will get one formula, M minus 1 into S plus D. How much it will come? M is how much? Because pile is group of 3 by 3. 3 minus 1 into S plus D, which comes out to be 2S plus D. And how much will be your? See, pile group capacity will be what? Pile group capacity UG. The formula for UG will be what? QUG, alpha C into 4 times of B, because your friction will be on these 4 faces. So what you will be get? Alpha 1, C is how much? 60. 60 into 4 times B is how much? 2S plus diameter of the pile is given D. हाँ, D तो दिया है 0.35. D दिया है 0.35. So अगर हमें ये वैल्यू मिल गई, so now you know efficiency is given as 1. So अगर efficiency 1 है तो यहाँ से आप उठा लीजिए QU1 is equal to QUG divided by N into QUP. That comes out to be, यहाँ पे इसको उधर ले लो, ये कितना है? 5934.6, which equal to 60 into 4 into 2S. होल से मल्टीप्लाई हो जाएगा ना, 4 से मल्टीप्लाई, 4. एक सेकेंड, 4 into 2s plus 0.35. अब यहां से only one unknown is there, s. Calculate the value of s, you will get the answer. Calculate the value of s, you will get the answer. हाँ, Shubham, you can skip in paper. These all, see, this question above 1 of void ratio, these are all questions you can skip in the paper. If you have more number of time, at last, if you are getting more number of time, you can attempt. But see, I have to solve here because I am doing for your practice, so I will solve. But if you are not getting time, you can leave here. Okay. See, kitna aa raha answer? Answer comes out to be how much? How much? Please tell me. कुछ आ रहा है? How much you are getting the answer? Please tell me. I hope answer would be coming 1.06. कुछ छूटा तो नहीं है? कुछ छूटा तो नहीं है? एक बार चेक कर लीजिए. I don't remember. कुछ छूटा तो नहीं है भाई, एक बार देख लीजिए. कुछ छूटा तो नहीं है? एक बार चेक करो. ठीक है. अल्फा 4b 4 टाइम्स ऑफ 60 यही होना चाहिए. ठीक है, यही हो जाएगा. c इंटू 4 इंटू m माइनस 1 0.35. हाँ, अल्फा वही आएगा. s की वैल्यू वही आनी चाहिए. s हाउ मच इट्स कमिंग? s आ रहा है यहाँ से. आना तो यही चाहिए. 1.06. आई होप 1.06 कमिंग. आई होप 1.06 आना चाहिए. चेक कर लीजिएगा. 1.06 मीटर. 12.18. आई होप. ऐसा क्यों हो रहा है? आना तो यही चाहिए. पीडीएफ में प्रोवाइड करवा दूंगा. हाँ, 12.18. कहीं दिक्कत हो गई है क्या? कुछ चीज छूटा होता है क्या? 2s प्लस 0.35 60 ये तो आना चाहिए. कहाँ दिक्कत आ रही है? ये भी तो वही है. पाई इंटू डी इंटू एल. ठीक है, चलिए इसको एक बार सॉल्व कीजिएगा. सॉल्व कीजिएगा. आई होप 1.06 के आसपास शायद आपको आंसर देखने को मिल जाए. अप्रोक्सीमेटली 1.06 के आसपास आपको आंसर देखने को मिलेगा. ठीक है ना? अगर सॉल्व करके देखोगे तो उसी के आसपास आपको आंसर देखने को मिलेगा. शायद हो सकता है कोई एक आध वैल्यू ऊपर नीचे रह गई हो. ठीक है ना? पॉसिबिलिटी बीइंग कोई एक आध वैल्यू हो सकता है ऊपर नीचे रह गई हो. ठीक है, बट अगर देखोगे तो देखो ऐसे भी कर सकते हैं हम, क्योंकि देखो सी तो दोनों तरफ कैंसिल आउट होने के चांसेस ही है. ऐसे रख के देख लो. चलो ऐसे रख के देख लो कि अल्फा तो कैंसिल आउट हो ही जाएगा दोनों तरफ. सी इंटू पाई कितना है? पाई डी है 0.35 इंटू है एल. एल है, अरे हमने एल से मल्टीप्लाई नहीं किया ना यहाँ. 4b इंटू एल. एल 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 से मल्टीप्लाई. हाँ, एल देखो अब डिवाइड करो. 12.8 आ रहा है. एक एल बच रहा था ना. एल से एल एल एल. वी हैव नॉट टेकन हियर एल भाई. यहाँ पे एल नहीं लिया ना. एल की वैल्यू हमने नहीं ली ना. एल लेना था ना, वही तो छोड़ दिया हमने. देखो एल की वैल्यू अब आ गया 1 पॉइंट समथिंग 2 के आसपास आ रहा है. हाँ, 1.06 ही. ठीक है, ऊपर नीचे करके 1 पॉइंट हमारे पास 06 आ जाएगा. ठीक है, वही मैं बोल रहा हूँ क्यों नहीं आ रहा था. बट हमने क्या किया, 4b तो ले लिया, बट थ्रू आउट लेंथ है ना, पूरे पाइल की जो स्क्वायर वो लेंथ भी आ जाएगी ना. ठीक है, एल आ जाएगा भाई. इस चीज का ध्यान रखिएगा थोड़ा सा. ठीक है ना, वहां पे क्या आ जाएगा, एल की वैल्यू आ जाएगी. ठीक है, तो यहाँ पे जैसे एल ले लोगे आप, आपको आंसर मिल जाएगा. ठीक है, तो आंसर कम्स आउट टू बी 1.06. चलते. ठीक है, चलिए जल्दी से इसका आंसर हमें बता दीजिए आप लोग. हमने बहुत आपको आंसर्स बताए हैं. अब आपका एक आध दो काम है, एक आध दो आंसर्स आप लोग बताओ भाई. इसका आंसर बताइएगा जल्दी से. शुभम, नरेश, आपको मैं पीडीएफ प्रोवाइड करवा दूंगा. पीडीएफ प्रोवाइड करवा दूंगा, इसका आंसर बस बता दीजिए। ठीक है, क्या हो जाएगा आंसर? बताओ। चलिए आप लोग बताइए, नहीं तो हम बताते हैं, कोई दिक्कत नहीं। ठीक है, तो देखो क्या बोला है, D15 फिल्टर बाय D85 प्रोटेक्टेड फिल्टर लेस देन 5। ये बेसिकली किसके लिए होता है? नो सिग्निफिकेंट इन्वेशन ऑफ पार्टिकल फ्रॉम द प्रोटेक्टेड मटेरियल टू द फिल्टर। ये किसके लिए होता है? नो सिग्निफिकेंट इन्वेशन ऑफ द पार्टिकल फ्रॉम द प्रोटेक्टेड मटेरियल टू द फिल्टर। इसके लिए हम क्या यूज करते हैं? D15 फिल्टर बाय D85 प्रोटेक्टेड लेस देन 5। ठीक है, तो ये ध्यान रखिएगा। चलिए अब आगे देखिए क्या है आपके पास। फाइंड द एक्टिव अर्थ प्रेशर एट द बेस ऑफ द वॉल 10 मीटर हाइट ड्यू टू सिर्फ यूडीएल के कारण। अब एक चीज ध्यान रखना, इसमें आपको सॉइल के बैकफिल के कारण नहीं बोला है, मतलब जो सिर्फ ऊपर की तरफ यूडीएल आ रहा है उस यूडीएल के कारण पूछा है। तो एक्टिव अर्थ प्रेशर है तो के क्या हो जाएगा? 1 माइनस साइन फाइव डिवाइडेड बाय 1 प्लस साइन फाइव। 1 माइनस साइन फाइव डिवाइडेड बाय 1 प्लस साइन फाइव, ये हो जाएगा 1 माइनस साइन 30 डिवाइडेड बाय 1 प्लस साइन 30। तो ये आ जाएगा 1/3। ये आ जाएगा 1/3। आपको पता है सरचार्ज के कारण जो एक्टिव अर्थ प्रेशर होता था वो क्या होता था? जो भी वैल्यू है किसकी? अर्थ प्रेशर कोएफिशिएंट की, और उसको जितनी भी वो सरचार्ज ऊपर लग रही है उससे आप क्या कीजिए? मल्टीप्लाई कर दे। तो सरचार्ज कितना आ रहा है? 30 किलो न्यूटन पर मीटर स्क्वायर का। ठीक है ना, तो हाइट का तो कोई लेना देना है नहीं, तो यहाँ कितना आ जाएगा? 1/3 के है, और ये वैल्यू कितनी है? 30। तो आंसर कितना आ जाएगा? 10 किलो न्यूटन पर मीटर स्क्वायर विल बी योर आंसर। तो 10 किलो न्यूटन पर मीटर स्क्वायर मेरा क्या आ जाएगा? आंसर आ जाएगा। समझे? क्लियर है? तो आपको बस सरचार्ज का पूछा है, तो ऐसे केसेस में भी ध्यान रखिएगा, पूछता है क्वेश्चन। ठीक है, Which of the following statement is correct? देखो, negative skin friction in precast piles can be reduced by painting the pile surface with bitumen। obvious ही बात है, प्रीकास्ट पाइल में अगर आपको नेगेटिव स्किन फ्रिक्शन से बचाना है तो उसको क्या कीजिए? थोड़ा सा स्मूथ कर दीजिए पेंट करके बिटुमिन से या ग्रीस से, तो उससे कम हो जाएगा। लोअरिंग द वाटर टेबल में इंक्रीज नेगेटिव स्किन फ्रिक्शन इन, ऑब्वियस ही बात है, वाटर टेबल लोअर होगा, सॉइल की इफेक्टिव स्ट्रेस बढ़ेगी, नेगेटिव स्किन फ्रिक्शन बढ़ जाएगा। अब अदर दो देखो, नेगेटिव स्किन फ्रिक्शन कैन बी इंक्रीज, अरे भाई इसी का तो उल्टा है, अगर ये सही है तो ये गलत। लोअरिंग द वाटर टेबल, लोअरिंग वाटर टेबल से डिक्रीज नहीं करेगा क्योंकि इफेक्टिव स्ट्रेस जो है बढ़ जाता है, तो इसीलिए ए और बी सही है। तो आंसर हो जाएगा क्या? ओनली ए एंड बी। आंसर्स कम्स आउट टू बी व्हाट? आंसर्स कम्स आउट टू बी ओनली ए एंड बी। ये भी चीज हमें पता है। ठीक है, इसका भी सॉल्यूशन देखिए यहाँ पे मेंशन्ड है, सॉल्यूशन यहाँ पे मेंशन्ड है। आगे चलते हैं। दिस वाज योर लास्ट क्वेश्चन ऑफ टोटल एचपीसीएल के जितने भी क्वेश्चन है। क्या बोल रहा है? एक सर्टेन टाइम लैप्स है, क्ले अचीव 50% एवरेज कंसोलिडेशन, बी जो है 20% एवरेज, फाइंड द रेशियो ऑफ कोएफिशिएंट ऑफ कंसोलिडेशन। तो आपको सीवी का रेशियो पूछ रहा है ए और सीवी का रेशियो पूछ रहा है बी, इन दोनों के बारे में बताइए। तो हमें एक चीज ऑलरेडी पता होता था, टाइम फैक्टर टीवी इज इक्वल टू सीवी इनटू टी बाय डी का स्क्वायर। तो अगर टाइम फैक्टर टीवी ए के लिए लिखोगे तो क्या हो जाएगा? सीवी ए के लिए इनटू टी बाय डी का स्क्वायर, क्योंकि वो टाइम और ड्रेनेज पाथ क्या रख रहा है? क्ले है, ड्रेनेज पाथ की लेंथ सेम है। टीवी बी के लिए लिखोगे तो क्या हो जाएगा? सीवी बी इंटू टी बाय डी स्क्वायर। तो यहां से अगर मैं सीवी ए लिखना चाहूं, सीवी ए क्या हो जाएगा? वो हो जाएगा आपके पास टीवी ए इंटू डी स्क्वायर बाय टी, और यहाँ पे हो जाएगा सीवी बी इज इक्वल टू टीवी बी इंटू टी बाय सॉरी डी स्क्वायर बाय टी, डी स्क्वायर बाय टी। तो यहां से देखो आपको रेशियो इसका इसका चाहिए था, तो ये दोनों तो है सेम ही है, ये दोनों कैंसिल आउट। आपको टाइम फैक्टर उसने दे दिया है, अगर 50% कंसोलिडेशन के लिए 0.2 और आपके पास 20% कंसोलिडेशन के लिए 0.02, तो यहां से लिखोगे CVA बाय CVB विच इज इक्वल टू क्या बचेगा? यहां से देखो क्या है आपके पास? TVA डी स्क्वायर बाय टी, TVB डी स्क्वायर बाय टी, क्योंकि ये दोनों कैंसल आउट हुआ तो आया क्या फॉर्मूला? CVA बाय CVB इज इक्वल टू TVA बाय TVB, और वो आ जाएगा आपके पास 0 पॉइंट कितना है? 0.5 0.2 डिवाइडेड बाय 0.03 विच कम्स आउट टू बी 20/1। ये आएगा नहीं 20/1 नहीं 20/3 20/3 सॉरी 20 20/3, अरे मिट जा भाई, 20/3, और 20/3 मतलब आपके पास अप्रोक्सीमेटली 10:1.5। अब यहाँ पे दिक्कत यही है, इस क्वेश्चन में दो ऑप्शन सेम है, तो कहीं ना कहीं देखोगे 20:3 भी सही है तो 10:1.5, क्योंकि देखो अगर इसको और छोटा करोगे तो वही आ जाएगा 10:1.5, बट जनरली उन्होंने आंसर जो 20:3 दे रखा था, तो जनरली हम लोग इसके साथ जाएंगे, कोई दिक्कत नहीं है। तो आंसर क्या हो जाएगा 20:3। मुझे लगता है उनको 10:5 देना होगा, उन्होंने 1.5 कर दिया होगा, तो आंसर क्या हो जाएगा 20:3 हो जाएगा। These are all your 55 questions which was asked in HPCL officers. Tomorrow I will be coming with all the previous year JEO and practice level questions for soil. In that session, we will also do many questions related to soil which can be asked for HPCL. Okay, so this was your last question, 20:3. We will be getting the answer. This was your last question. Understood? For PDF, those who want, you can please comment on this stream. After the video will be public, you can comment on this video, you can subscribe the channel. For PDF you can comment, I will provide you I will provide you the link for the PDF. Okay, so please subscribe this channel, and if you like this session, please comment. And if you want all more sessions on these HPCL exams, please comment. I will take all or more sessions on different types of subject for HPCL like this. Okay, thank you all of you. Bye bye. Jai Hind. मैंने भी नहीं सोचा।